is mostly to revise some concepts. So count distinct elements in every window. Why is this important to me? That's because while solving this problem, I discovered there is the delete keyword in Python to delete keys in a dictionary. And why do we need to delete a key in a dictionary and not just set it to zero is what this problem is about. Given an array of integers and a number k, count the count of distinct elements in every window of size k in the array. So the naive approach is where you traverse through the array from index n minus k, and at every um, each of these windows you check how many distinct elements are there. So yep. So what does it do exactly? For a given array, traverse through index 0 to n minus k to avoid array out of bound exception. Again, very, very important, these small things. And then traverse array from I to I plus k. Traverse the window, and if the element is not present in the prefix of that window, then count plus plus. So, see what it's doing here. Window of the ARR of I plus k. Right, so if we go back to what we were looking at, yeah, my Pomodoro timer actually went off. Yeah. So, count distinct this. And inside each of this, you have a count 0. You go from 0 to k. You have a j. If j is equal to 0 and j less than I, j plus plus, if any. So basically, if it is distinct, then you add it. If it is not, then you don't. That's it. Return the count. So you need to count distinct elements. What happens here? If it is equal, then break. What happens here? If j is equal to I, what does this mean? Okay, yeah, so it went to the end without breaking. Got it. So it went to the end without breaking inside this loop. So it returned the count. So that's it. So you just like, you know, went into the loop, got that window for each element, just kept on comparing it to all other elements. If it, reach the end without having a single, duplicate, then you add a counter, like add one to the count, then to the next element, then again look at everything in the array, the rest of it, like that. So that's that. And here J goes from 0 to I. So I usually starts with 0, and then hmm, what's happening here? So let's take an example 1 1 1 2 1 3, right? 1 2 1 3. Then let's say 1 2 1 we have, and then this is 0 1 2 1. I is 0 and J is also 0. Then that's not gonna happen. Then I is gonna be 2. Okay, I is gonna be 2. I is gonna be 1 and J is still gonna be 0. So it's gonna keep going. It's not matching. So, and then I is gonna be 3 and J is gonna be still starting from 0. Yep. So for each element is checking the elements before it. Hmm, makes sense. I understand. For each element, it's checking the elements before it, and if there's any um, matches, then you break. Cool, makes sense. Using maps, we need to store the distinct element in Windows so we can get the unordered map. So here we take an unordered map. Then there's j and I indexes. For while j is less than n, map of a of j is plus equal to 1. If j minus I plus 1 is equal to k, then push back this to the answer and reduce the count of the element at a of I. And if a of I is equal to 0, then erase, that is delete it, and then increase I again here and keep going, and then outside keep j going. So basically j less than 1, it will keep running. Count distinct elements in every window. Count distinct elements in window. Keep code. Feel like I've solved this thing somewhere. I don't know if this is on lead code though. Let me know if you guys found it on lead code or something. Feel like I've solved it somewhere. Okay, just share this tab instead. Just see how they're doing it. And everyone is doing it in the same way, it seems like. So in range K, if the array at I is equal to 0, then a distinct count. Traverse, okay, so it's just traverse to the first array and like traverse to the first window and store count of every element and hash map. So it stores the count of every element, and then if map of array of I is equal to 0, then store the distinct count. So how many distinct elements were there? Cool. Now print distinct count in the first window and then go from k to n, and if map of array of I minus k is equal to 1, then distinct count is equal to minus 1. Cool. Yeah, so it's basically removing the last element of that window, that was I, and then reducing it. Remove the first element of the previous window if there was only one occurrence, then reduce distinct count. Add new element of current window, and if this element appears first time, increment distinct counts. If 0, then increase, and then also add 1. So that seems to be it really. This, what's it doing? So there's this distinct count variable that it's keeping, and like in other solutions, they have told you to calculate, like get the length of the dictionary at every point. But I think this is a better solution. Traverse through, like get like first initialize the distinct element count, traverse to the first window and store count of every element in the hash map, print count of first window, which is this distinct count, and traverse through the remaining array. So if remove the first element of the previous window, if there was only one occurrence, then reduce the distinct count. So I minus k is equal to 1. So it reduced. Is it removing from I minus k? add the new element of the current window. So it'll add, if this MP of error of I is equal to 0, it'll add it. And it'll increase the string count by 1, and it'll increase the count of this guy by 1 as well. So it's pretty simple, but I feel like sometimes we try to overcomplicate solutions like these, and just like, I feel like the solution that I just saw right now, it makes more sense than having to get the length of the dictionary at every time. So every time you like add or remove, like, from that window, like you remove the element from the last end of that window and then add the element at the complete right end of the window, and then you know see how many distinct elements are there by getting the length of the dictionary this at any time. But that is not a good thing to do, right? That's a big O of n operation in the worst case. So that is not a good thing. This distinct elements count thing is way better. That doesn't need you to do anything of that sort. So this is a really good solution, I feel like. And it's pretty simple as well. Yeah, I might solve this myself. Yeah, again, just to do the right thing. Okay, thank you. Bye.